This is the classic 15 puzzle made in Excel using VBA. The aim of the puzzle is to take a scrambled grid and to slide the tiles around in order to reorder it 1 to 15. And I'm going to show you how to make this yourself. So, starting with a blank spreadsheet, the first thing I want to do is format the cells so that it looks like the puzzle. So let's make the cells a square shape by making sure the height matches the width. So I've chosen 80 by 80 pixels, and let's set our puzzle grid to be this 4 by 4. So now I've selected that range, I can rename the range up here by typing in whatever you want to name it. I'm going to call it grid, and that just makes it really easy for me to select that range, and it makes it really easy in VBA to reference that range when we come to code the mechanics of the puzzle. Next, I'm going to make that grid a bit prettier, different from the rest of the spreadsheet. So let's give it a border. And of course, our numbers or our numbered tiles are going to appear in here. So I want to make that a bit more visible and make it centered. Great. So that's how our tiles would appear. And the last bit of aesthetics is I want to make the blank cell, the empty space, a bit different to the rest of the range. So again, I'm just going to select my grid and then use conditional formatting to do that. So I'm going to say format only cells that are blank, and we will fill it with a color just so it looks different. Okay. Now, of course, our puzzle will be completely filled, so there'll only be one empty cell. So now's a good time to pause the video and to make sure you formatted your spreadsheet like this before we move on to actually coding the mechanics of the game. Right, let's start writing some VBA. So I've already opened up the Visual Basic for Applications window. You can open this by pressing Alt F11 or by going to the Developer tab and clicking Visual Basic. If you don't see the Developer tab, then if you just do a quick Google on how to show that on your ribbon, you'll be able to find out how to do that. The first thing I want to code is to actually reset the puzzle, put it in a solved state. So I just want it to fill this puzzle 1 to 15 and have one empty space. So I'm going to insert a module and I'm going to add a subroutine to do this. Sub reset. And this is going to reset the puzzle to a solved state. So it's really simple. We just want to go through the puzzle 1, 2, 3, 4, 5, 6, 7, add in the numbers until we get to the penultimate cell. So in this case, there's 16 spaces, and so we need 15 numbers. So we could say for I equals 1 to 15, next I. This will iterate through the numbers 1 to 15, and we just need to say in our grid, put the number in the right place. So remember, I named my range grid. I can reference that in VBA by doing range grid, and I can reference each cell within that range by doing item. So item 1 would be the first cell, item 2 would be the second cell, and so on. And that moves across the rows and then the columns. So if I just do item I and do select, I can show you what that will do. You can see it's just moving through each cell in the range. But we don't want it to select it, we want it to populate it. So let's say item I equals I. So item 1 equals 1, cell 2 equals 2, and so on. And that's going to go up to 15. And there we go. Something else I'm going to add before we do that is to actually just clear the range. That's because when you're in a scrambled state, this cell might already be populated with something. So if that said 3 and that was our empty cell there, if I run this as it is, it leaves that 3 in there. So I'm just going to say clear the range before we do that. So range grid dot clear contents. Now this is important. If I did dot clear, that would in fact remove all of the formatting. So the borders, the font size, the conditional formatting would all be removed. So I choose to do clear contents instead, and that will just remove the values within the cell and keep the formatting. So now when I work through this, it clears the range and then it will repopulate it in order. I'm actually going to make one adjustment to this to give us a bit more flexibility. So right now, this is assuming that our grid is a 4x4 grid and has 16 spaces. But if we wanted to be able to extend the grid, maybe like this, then that's not going to fit it correctly anymore. It's only going to go up to 15. So what I'm going to do instead is just count the number of cells in that range. So range grid.count will give us a number of cells in that range in our grid. And I'm going to -1 because we don't want to fill the last cell. And that way, when I run it now, F5 to run a subroutine from Visual Basic, it populates all the cells up until the penultimate space. So now we've got the start of our puzzle, we actually want to be able to slide some of these tiles around. So if I click here, it would slide into the empty space. Also, if I click here, that would slide into the empty space. So let's think how we want to do this. Well, first, VBA needs to know which tile we've selected. It needs to know that it's next to an empty space, and then it needs to move that value into that space and clear it from the one it came from. So I'm going to add this code to sheet 1, which is the sheet we're in within the VBA project, because this allows us to use the worksheet selection change subroutine. So what this does is it looks out for a change of selection in the current sheet, or in the in sheet 1, should I say. And it will give us target, which is the range that has been selected. So let me just demonstrate that. I'm going to just print out the address of the cell selected, so target address. So whenever I click a cell, the address is being printed down here. If I click multiple cells, it gives me the range. So what do we actually need to look for? Well, first of all, we need to know that they've selected only one cell because we can't slide multiple tiles. So let's count the range, the target range. That is the range the user has selected, and make sure it's only one. If target dot count equals 1, then execute this code in here. Otherwise, ignore it. Next, we want to make sure that the selection is within our grid and not outside of it. So I'm going to use the intersect function here. What this does is it takes two ranges or more, in this case our target range, the range that's been selected, and our grid. And it will return the intersection of those two ranges. So to check if these two ranges intersect, we need to say that intersection is not empty or is not nothing. So we can go if not intersect is nothing then. So what this is doing is it's checking, is this intersection nothing, i.e. does it not intersect at all? And then we're saying we don't want that to be true. So basically we are saying there is an intersection here. Let me demonstrate that by outputting a little note. So if you watch down here, you'll see this get printed when I select a cell within the grid. When I select outside the grid, nothing happens. Inside the grid, the code is executed. But if I set multiple cells, nothing happens because it has to be only one cell selected. Great. So now we know that the user has selected one cell within our grid. The next thing we need to do is check if it's next to the empty space. And I'm going to use the offset function to do this. So we know, for example, if I've selected this number, that's our target, and we need to check one above, one below, one to the left, and one to the right. So that's easily done with the offset. So let's just consider checking the one above first. So this will be our target offset by one row upwards, so -1 because we're currently in row 4 and therefore we're going to offset to row 3, and no change in the column. That will give us the cell above it. And I can check if that's empty. So I can say if target offset -1 0 equals nothing, then end if. That means it's blank. So it will stop here if that is blank, otherwise it won't. And what I could do is repeat this and have one for -1 row, +1 row, one for -1 column and +1 column. And that would look like this. And I select a cell within the range. Selecting that 6, nothing happens because none of the cells around it is blank. If I select the 11, it stops here. It's recognized that if you offset it by one row, so row 5 and no columns, it's empty. So it's found our empty cell. So now we've found the empty cell, let's move it, or move the tile that we've selected into that empty cell. So we selected number 11 here, and it needs to slide into this one. So we can do target offset by the same offset as the if statement above, equals target. Let's see what happens there. There we go, it's filled it with 11. But now we need to empty that, the space that we moved the tile from. So I'm just going to slide this back up here, and I'm going to use clear contents again in order to clear that original space, like so. And we just need to repeat that for each of those ifs, making sure we adjust the offset. I've just finished updating each of the if statements to make sure that the empty cell it's looking at is indeed in the grid, and I've added some comments to the code. And that's it. That's the mechanics of the puzzle done. So if I start clicking these tiles, they slide into the empty space, as you would expect. And the edges are no longer a problem. So now we just need to actually scramble the puzzle so that we can solve it. Now we can scramble it manually by clicking each of these tiles, or even by using the arrows to move them around, but that's a bit tedious. So let's automate the scramble. So to scramble this, I'm going to go back to our module, and I'm going to add a new subroutine called scramble. And this will scramble up the puzzle. There are several ways to do this, but the most simple way I came up with was to simulate what we were doing manually. And that is to find the empty space and then select a random tile around it to move it into the empty space, and then to repeat this as many times as we felt necessary. So to find that empty space, I'm going to just go through every cell in our grid and check if it's empty. Once we found an empty cell, we go, this is our empty cell, stop searching. So for each cell in our range, if that cell is empty, my cell, then we have found the cell, so we can stop searching. So I'll do an exit 4 at the bottom here, but we need to record which cell it is. So I'm just going to set this variable to be the current cell we're looking at. And that finds us our blank cell. Now we need to randomly pick one of these 4 tiles around it. So I'm going to use some functions here to generate a random number between 1 and 4, and then I'm going to use a select case to tell VBA what to do for each random number. So let's say option 1 is this, option 2 is this, and so on. So the R&D function gives us a random number. So if I just show you in the immediate window here, it gives us a random number between 0 and 1. But we want 1 to 4. So if I actually times that by 4, that will start giving us numbers between 0 point something and 3 point something. So we actually want it 1 to 4. We could do 0 to 3, but let's stick with 1 to 4 as we planned. So I'm just going to add 1 to that. That now gives us a random number between 1 point something and 4 point something, but we don't want the decimal spaces, so let's make it an integer. And now we get a random number 1, 2, 4. When using the R&D function in Excel, I tend to use the randomize statement before it, and that just means that the seed used to generate the number is randomized rather than following a sequence. And it gives us a bit more randomness. So let's do our select case. Select case, and we're going to enter the statement we came up with below. So what this is saying is take this case, which is going to be the numbers 1 to 4, and for each of those cases, we're going to do something slightly different. So case 1, case 2, case 3, and case 4. So that means if this is 1, it will execute whatever code follows this. And I'm going to keep it all in one line by using the colon because it's a small amount of code. And I'm basically going to assign the offset. So I'm going to say which tile to select. So if it's case 1, we want to select the cell above it. So I'm going to say the row should be -1 and the column should remain the same. Case 2, we're going for this one, the one to the right. So in this case, the row remains the same and the column is +1. I just noticed I've missed an equal sign there. And I'll repeat this for the final 2 cases. And that will find a random tile around it, which allows us to select based off these offset values R and C. So let's go with, so blank is our empty cell, offset by R and C dot select. So that's going to select a random cell next to the blank cell. So let's run that code. There we go. It's picking a random cell and moving it. Now, of course, we haven't considered what happens if it picks a random cell outside the grid. but it doesn't really matter because nothing happens here. So we want to repeat this scramble many times to really scramble up the puzzle. So I'm just going to add an iteration over here. For I equals 1 to 100, say, that will apply the scramble about 100 times. I say about because sometimes it's going to select a cell outside the grid, in which case it won't change the grid at all. Next, I. And that's going to repeat this code 100 times. But we need to keep track of the blank because that's not going to stay in the same place. So right now the blank is D5 and therefore blank is cell D5. And then say it randomly picks this one, blank is now moved to the cell we just selected. So we can just say set blank to the cell just selected, so the current selection. And that works nicely because we're selecting it immediately before, so we know that the current selection is the new blank cell. The only exception to that is if the cell selected is outside the grid. And when that happens, nothing changes. So if this is the current blank cell, E4, and then we pick the cell just outside of the grid, then E4 remains the blank cell. So what we can do is just check, is our current blank cell, E4, still blank after selecting a tile around it? If not, then we know the new blank cell is the tile we just selected. So if is empty, oh sorry, I should say if not is empty, blank, then, so that means the empty cell has been replaced with a number and therefore the empty cell has moved. Then set blank to selection. So let's just run through this. I'll put a breakpoint here and a breakpoint here just to show you what's going on. So we found our blank cell already and we know it's E4, and now 100 times we're going to repeat this bit of code. So first it will randomize a number between 1 and 4. In this case it's given us a number 3, and therefore we're going to offset it by 1 in the rows and 0 in the columns. And it will select that. This will trigger the existing code in the worksheet selection change to slide the tile. So I'm just going to press F5 to move past that to the next breakpoint. And it's selected the tile. Next, it checks if it's still blank or not. If it's not, then it sets the new blank tile, new blank cell to the currently selected cell, which is E5. And that will repeat. So again, it's moved that way. This time it's outside the grid, so it won't actually reassign the blank cell. It's going to keep it as E4, and it's going to keep doing this 100 times. So if I just press F5 and run through all of this without the breakpoints, you can see it scrambles it 100 times. Let's see that again. Great, so if I just reset the grid using our previous subroutine and then run the scramble, you can see it scrambling it, but not very well. So maybe we want to do more. So let's do 1,000 scrambles. That's going to look a bit crazy on your screen, and it takes a while. I'm just going to hit escape to break that. Oh, no, it's going. There we go, it's run through. So you can see it's a bit problematic because it's updating the screen a lot. So to avoid that, I'm just going to add in application.screenUpdating equals false. That's going to turn off the screen updates, and down here I'll turn them back on once we finish running our code. And there you have it. That is the scramble code complete. I hit F5 and that's scrambled our puzzle for us to attempt to solve. And that's it. That's all the code behind this puzzle. If you want to make it easier to scramble and reset the grid, you can do so by going to your macros and giving it a keyboard shortcut. So reset, I can hit options and I can add a shortcut key here. It's control and any key of your choice, but because those are already assigned to useful shortcuts, I'm going to actually press shift as well. So shift R means that if I press control shift R, it will run this macro. I'm going to do the same for the scramble. I'm going to do control shift S. Okay. And now when I press control shift R, it resets the grid. When I press control shift S, it scrambles the grid. And that's the end of the tutorial. You now have a fully working 15 slidey puzzle. And if you don't want it to be 15, you can extend the grid. So I can go insert here and shift right and make the grid a 5x4. Control shift R resets it, control shift S scrambles it. So you can make the grid as large as you like because we've written the code in such a way that it's flexible. So again, control shift R to reset, control shift S to scramble. And there you have it. You can now start trying to solve this puzzle. As an extra challenge, you may want to add in a move count. So how many moves did you solve the puzzle in? You might want to add in some buttons to reset and scramble the puzzle also. If you want a copy of my version of this spreadsheet, then please drop me an email. I'd be happy to send you a copy. Otherwise, I hope you found this tutorial useful and have been able to create the puzzle yourself. Thanks for watching.